Okay, we continue our exercise. So we calculate v and n prime is equal to 28.36 plus j 60.72. The module is square root of this squared plus this squared. It's equal to 67. And the argument is arctangent of this divided by this, and we have 65 degrees. Now let's try to calculate, so I have to remember all these results. So let's calculate the power consumed by the load and the power produced by the network. Okay, let's we have everything, so it means S1 prime, we can call this power S1 prime, S2 prime, and S3 prime, and the total we call it S prime. This is, we can say that this is V1 n prime times the conjugate of I1, and this is V2n prime times the conjugate of the current I2, and this is V3n prime times the conjugate of the total, the third current in phase 3. Okay, so here we have, I hope I will have, we calculated this, the V1 n prime, the argument is 17.58, here is 188.73, argument minus 136.75, here it's 285.79, argument was 118.72 degrees, times the conjugate of the three currents. The currents I1 is 6.22, argument is plus, because it's a conjugate, plus 4.22. Here it's 4.09, argument is 124.22. Here the current is 5.475, and the argument is minus 135.42 degrees. And the result, we will write it again. We will write it here if we S1 prime, S2 prime, and S3 prime, and the total S. Here the result, I will write it here. So we have, the result is 1250.83, argument it's 1756 plus this one, it will give us 21.8 here in volt ampere. S2 prime, this one times this one will give us 772.67, argument is this plus this will give us minus 12.53. The last one is 1564.73, argument this plus this will give us minus 16.7, and here it's also minus 12. Okay, So the result, I will write the active power and the reactive power here. This times cosine 21.8 gives a result of 1161.38 plus j sine of 21.8 times this will give us a reactive power of 464.52, and here we have active power of 754.27, this times cosine this, and here it's negative because it's minus 12, and sine of 12.53 times this will give us a negative value, and it's equal 167.63, and here will give us positive value. Cosine of 16.7 will give 1490.73, negative as well the reactive power. Sine 16.7 times this will give us 449.64, and if we do the sum of the three, so we get here 3,414 active power taken by the load, and the reactive power negative of 152.75. This is what we have: S1 prime, S2 prime, S3 prime, and the total power. So we'll write them again here because I need a space here. 1161.38 plus the J for 64.52. Here is 754.27 minus 167.63, and here it's 1498.73, and here minus J 449.64, here 0.64. Okay, so I can write the total power, 3,414.38 minus J 152.75. So we calculated the power taken by the load, and now we have to calculate the power produced by the generators S1, S2 and S3, and total power produced by the generators, and this power should be equal to this. If it's equal, it means that the calculations are good. Here we can say that it's V1N times I1 conjugate, V2N times I2 conjugate, here V3N times I3 conjugate. Here voltage, this is 220, 0 degrees, this one 220 minus 120 degrees, and this is 220 plus 120 degrees. I1, I2 conjugate. I1 is 6.22, and the argument is 4.22. Here it's 4.099, and the argument is 124.22. Here is 5.475, and here we have minus 135.42. 2. So we can write the result. This time this will give us, we'll have to turn. I hope that I calculated it. So I have the result here in front of me. So I have 1368.84 and the argument is 4.22 degrees. Here, this times this will give us 900.68. Argument this time plus this will give us an angle of 4.22. Okay, and here we have 204, and the argument this minus this is minus 15.42, and we can calculate the real power, active power, reactive power, active power, the reactive power, the active power and the reactive power. So we have this time cosine this, it's 3,365.13 plus J 100.73. This times cosine this will give us 898.24 plus J sine of 422 times this will give us 66.28, and this times cosine this will give us 1161.14, and reactive power is negative. It's sine 15.42 times 1204 will give us 320.27, and if we add all this we obtain 300. So here 3,424 about, and here we have minus 153.26. So we see that we are very, very close. Of course, we could be closer if it was very, very accurate calculations. So we finished here, and we found that S produced by the generator is equal to the power taken by the load. And every phase, the powers are different, as you see here. They are different. If the neutrals were connected together, the powers here, these phases will be the same. Okay? And thank you very much. I think I finished. I calculated everything. And thank you very much. I hope that you understood. The method is not complicated. We use the Ohm's law, Kirchhoff's law, and method of solving system of linear equations using the determinant method. Okay, thank you very much.